different cases of electrolysis. So electrolysis of melts. It's actually very easy. Electrolysis of melts is easy. We just separate our substance into ions. We have sodium chloride. Yes. When we melt it, we have two types. We have melts and we have aqueous solutions. If we use melt, means we just melt it. We don't dissolve it in water. We just take our salt and melt it. If we melt, we give some electricity. It dissociates into two ions, cation sodium and anion chloride. See? Two of them are here. They dissociate and move in the direction of anode and cathode. All the ions of electrolytes are for attention in this case. And if we are talking about aqueous solutions, not melts, but about aqueous solutions, it will be a bit more complicated. We have to pay attention on different factors, as you can see on the screen. We have to pay attention on the nature of the ion, what kind of ion we have, the nature of the solvent, if our solvent is water, or actually in aqueous solutions, our solvent is always water, but if it's not water, but if we have another solution, another solvent, in this case, we have to pay attention to the nature of the solvent. Okay, the concentration of an electrolyte. If we have more electrolyte, we will get more ions. If we have less electrolyte, we will have less ions. But even if we have a lot of ions, much concentration, there are some limits. At one moment, the concentration increase, electrolytes will be increased. But after that, if the concentration is too big, there will be no space for electrolysis. So electrolysis at one moment will stop. So concentration of electrolyte also plays role in the electrolysis. Then material of an electrode. Electrode can be made from carbon, from metals, from different things. We don't know which electrode we use. So material of electrode. Then you see temperature and density of electrical current. Density of electrical current is this one, E, amperes. If we give more electricity, we will get faster and more electrolysis. Now pay attention at this table. These are metals. So this one is hydrogen. The red one is hydrogen. All the others are metals. And here we have potential. This is a table where the potential of metals decreases. Look. This one, lithium, had a higher electric potential. Its potential is higher. Gold had the lower potential. It means this one, the yellow ones, are active metals. We call them active metals. The green ones are metals with medium activity, but they are anyway more active than hydrogen. Okay? And these ones are weak metals. You have to remember this table, but not by memory. You don't have to memorize like everything, like first lithium, the second one potassium, then this one, not like. You just should know the yellow one, lithium, potassium, calcium, sodium, and aluminum. You should know that they are very active. You might forget this order, just you have to memorize them. Then you have to know that this one, and you have to memorize the last one, the blue ones, they're very weak metals, passive metals. If you remember all the active metals and all the weak metals, you will know that the rest ones will have the medium activity. So they are very active, they have a medium activity, but still more active than hydrogen. These ones are very, very passive, very weak and passive metals. Okay? We need to know it in electrolysis because the active metals, actually, they can push hydrogen. Example. If we take an active metal, the first one you see, lithium. Let's take lithium, the first one. Lithium plus hydrochloric acid. What happens? Lithium we see is stronger than hydrogen. Yes, it's on the left. It's more active, it's very active, stronger. So this lithium will push this hydrogen. He will come here and say, hydrogen, get out. And take his clue. And this is what we will get. So lithium will come and stay instead of hydrogen here. Hydrogen will remain alone. He pushed hydrogen from here and takes his chloride. He will take the second one, for example, let's take iron. Yes? Let's take iron. Iron. And HCl, hydrochloric acid. What happens? Iron has a medium activity, but it's more active than hydrogen. It will also push hydrogen, and we will get iron chloride plus H2. You would take the last one. Look, let's take copper, or one of the blue ones. Let's take copper. Yes, copper. We know it's a weak metal. We would take hydrochloric acid. What happens? Copper needs to come, push hydrogen, take chloride. Yes, but look, it stays on the right side. It stays after hydrogen, so it's weak. You see, this is hydrogen. Copper comes after him, so he's a passive metal. He's weaker than hydrogen. He cannot push hydrogen, so this reaction will not slow. Okay? Because weak is weaker, and hydrogen is stronger. Here it's opposite. Hydrogen is weaker. This one is stronger. The one who is stronger, he can push the weaker one. Okay? And let's now discuss different cases of electrolysis in solution. So if we are talking about electrolysis in solution, there can be different cases. The first case, when we have a non-active metal, one of the last ones. Okay, we said from this ones. If we are talking about a non-active metal, it will be copper, hydrogen, argent, platinum, or one of them will be non-active or a passive metal. So, but not containing oxygen. We will talk now as salt. We are talking about electrolysis of salt. We will take a salt of a passive metal that does not contain oxygen. Let's discuss this reaction, and after that we will go, okay? Because it's over the end of the lesson. We have, you see, we have copper chloride. It's salt of copper. We said that copper is a passive metal. Yes, we have this one, copper chloride. Well, we say that copper is a passive metal. Why plus H2O? Because it's aqueous solution, it's right, and water will remain as well because we had water. What happens here? Which process of form? Why, as a result of electrolysis, we got these substances? Because this copper, here we dissociated copper chloride. It consists of two ions. Yes, copper. We know copper has a charge +2. Chlorine has a charge -1. Yes. Two ions. So what happens here? This copper, what it dissociated with the it's plus, positive. It's a cation. It goes to the cathode. Yes. Well, cathode. Copper went to cathode. It's 2+. To be discharged, it needs 2 electrons. It took 2 electrons from cathode because cathode is negative. It has a lot of electrons. Copper took 2 electrons from cathode and became neutral copper. We get it here. Chloride, negative, yes, minus. It went to anode, which is positive, and gave here 1 electron, but we have 2 chlorides. You see, chlor 2. 2 chlorides, so each of them gave 1 electron. Overall, 2 electrons were given. He gave 2 electrons, he became chlor 2, 0, neutral, right here. See? And the result of H2 is water, it remains like this. So this was the first case of aqueous solution, electrolysis of aqueous solutions. Okay. Next lesson, we will discuss other cases. Okay, so if you wish, next lesson we will discuss, and we will do an experiment. We will bring a galvanic element, and I will show you such an experiment. If you have questions, you can move.